welcome to today's deep dive. We've got something pretty mind-blowing for you today.
Yeah, we are decoding a massive paradigm shift in autonomous driving. And we're pulling from a bunch of sources for this, like an academic survey on world models and, an inside look at NVIDIA's new simulation tech.
Right. And to kick things off, just imagine spending years meticulously writing like 300,000 lines of life-saving code.
That's a lot of code.
Yeah. And then deleting it all overnight. Because that is exactly what Tesla just did with its full self-driving version 12. They just ripped out all the C++ and replaced it entirely with an end-to-end neural network.
Which is wild. We are fundamentally moving past the era where machines rely on those rigid, if-then rules. Traditional autonomous systems have historically been choked by deterministic logic.
Right, trying to explicitly hand-code a response for literally every possible edge case on a mapped road.
Exactly. Like, if a pedestrian intersects the path within 3 seconds, brake. But you simply cannot write a rule for every unpredictable thing that happens out in the real world.
Because trying to hand-code reality is essentially like bowling with the bumpers up. Every rule is just a physical boundary that some engineer has to anticipate.
Yeah.
But with this end-to-end neural network, it's fed on millions of hours of raw human driving video. It's essentially, well, it's like ChatGPT for cars.
I like that analogy. It learns the actual physics of the lane through millions of virtual gutter balls. It's learning the holistic behavior of driving rather than just, memorizing a list of boundaries.
Like a master chef who just intuitively cooks after watching millions of other chefs, rather than following a super strict recipe that fails if you're missing, like, one exact ingredient.
Precisely, which is why we're seeing this transition towards systems that learn by observing, but learning purely from raw video creates a massive problem.
Right, because how does the car safely practice dangerous edge cases?
Exactly, like a pedestrian unexpectedly stepping out from between parked cars. It can't exactly practice that by crashing in the real world.
Obviously not, so it has to somehow dream up those scenarios.
It does. And that requires building a simulated reality. According to the academic survey we reviewed, researchers are solving this through what they call world models.
Okay, world models, what
So
exactly?
the AI takes in massive amounts of multi-sensor data and compresses it into this latent state. But instead of processing every individual pixel of a video, this latent state just strips away the visual noise.
Like the shadow of a tree or, the color of a nearby car.
Right. It isolates only the pure geometry and physics that actually matter for driving. And once it isolates those key physics, the core mechanism of the world model kicks in. It predicts the very next frame of reality.
Oh, wow. So based on its current speed and steering angle, it rolls that stripped-down latent state forward.
Yes. The car is literally rehearsing futures before they happen. And to train that intuition, simulation technology has had to evolve drastically.
Right, like NVIDIA's Alpha Dreams.
Yeah, Alpha Dreams is a great example. It skips hand-coded virtual cities entirely. The AI acts as a generative engine, ingesting raw driving video and generating these interactive, real-time 3D environments right on the fly.
So the car learns how to drive by navigating a dynamic, hallucinated reality that perfectly mimics the physics of our world. I mean, that's incredible.
It really is.
But wait, I have to push back here. We're talking about a 2-ton vehicle operating at highway speeds based on a hallucinated reality.
That's the scary part for some people.
Yeah. If this neural network operates as a complete black box where it's just predicting the next frame, there's no traceable C++ code to debug when something goes wrong.
Yeah.
How can regulators or, you sitting in the passenger seat ever trust an AI that operates on intuition instead of traceable logic?
Well, that tension is the central debate in the industry right now. We are trading explicit explainability for real-world performance.
Right.
A hand-coded rule gives you a clear audit trail, but it breaks down completely when it encounters a chaotic edge case it wasn't programmed to handle.
Yeah, the bumpers aren't there anymore.
Exactly. A neural network loses that transparent audit trail, but it handles real-world chaos infinitely better because it actually understands the broader context of the environment, not just isolated rules.
Which means this paradigm shift goes way beyond autonomous driving. We're witnessing the transition from software 1.0, where humans write explicit logic, to software 2.0.
Yeah, software 2.0, where models just learn behaviors organically.
It's a huge shift.
It is, because when you realize an intuitive neural network can safely replace hundreds of thousands of lines of explicit code for a complex, high-stakes task, it demands we rethink how we build and trust digital systems as a whole.
It definitely leaves you with a massive question to chew on. If a black box model can replace explicit traceable code to pilot a car safely, What happens when this kind of learned behavior replaces explicit programming in other high-stakes domains?
Like the global financial system.
Right. Or even medical diagnostics. Imagine those running entirely on intuition rather than transparent code. It's a lot to think about. Well, thank you for joining us on this deep dive today. We really hope you learned something entirely new to take with you.